Sorry about that. I think that we went over on our time, and that's why it turned off on me. Sorry. Like I said, this is a little bit of a longer lesson. So I was saying, if you didn't understand what I was just saying, I was just making the t-table here. When x is 0, y is 3. When x is 1, y is 4. When x is -1, -1 squared is still +1, plus 3 is still 4. So here's my table. Now, if I want to graph the inverse, all I have to do is switch the x and y, remember? So I can just take the -1, 4 and call it 4, -1. The 0, 3 and call it 3, 0. And the 1, 4 and call it 4, 1. So now I'm going to plot those guys. So I'm going to have 1, 2, 3, 4. So what's going to happen here is I'm going to get 4 and -1. So we'll put -1 right about there. 3, 0 is right about there. And 4, +1 right about there. And I will graph this function like that. And what you will see is that right through the middle is your y equals x, and you have these mirror images of those two functions. Alrighty, so hopefully that was an easy way for you to do that. So the same thing's going to happen over here. I'm going to go ahead and do a linear example for you. 3x minus 10. So I'm going to go by maybe 5s. So, or 2s. Let's go by 2s. 2, 4, 6, 8, 10. Okay, so this is -10. And the slope here is 3 over 1. But since I'm going by 2s, I'm going to go ahead and times this by 2 over 2. So basically I'm going to get 6 over 2. And we know that 6 together is the same thing as 3. But it's going to be easier for me. 2, 4, 6, 8. It's easier for me now to graph this because I can go -10 and then I can go up 6, so up 2, 4, 6, and to the right 2. Okay, so just a little trick there for you if you're trying to figure out how you can graph these things. Sorry, the shadow here on my smart board is kind of weird. So there's my graph. What you're going to see is that you can have, starting here, go up 2, up 4, up 6, over 2, and then up 2, up 4, up 6, and over 2. All right? So what I would like to do is use those 2 points because I know that when x is 0, y is -10, and I went up 2, 4, 6, and over 2. So that means that x is going to be 2, and y at this point is -4. Okay? So I can use those points and I can invert them to find the inverse function. Alright, so instead of 0, -10, I'll get -10, 0. And instead of 2, -4, I get -4, 2. In this case, I only need 2 points because when you graph a line, you only need 2 points. So now, I'm going to come over here to my -10. I'm going to go 2, 4, 6, 8, -10. Okay? So -10, 0, right there. And -4, 2. 2, 4, and then instead of, we're going to be up there. And then I'm going to put these little guys here. Trust me, it's a lot harder for me to graph it with this crazy board than it is for you to do it at home. But hopefully what you're seeing there is, again, a mirror image. Here's 1, 1. And you can see that this red line here is the line y equals x, and you in fact have a mirror image happening right there. Beautiful. All right, so remember that when you are graphing this, I do want you to graph the function, its inverse, and the line, so you can see how it's doing that reflecting thing. Okay? And then here's some examples for you to do. Again, one that's linear, one that's quadratic. And then here is going to be our last, not last, but second to last problem. So for each function f, it says find the inverse and the domain and range of f and f inverse. Determine whether f inverse is a function. So this is like all crazy stuff here, okay? So just let's attack this guy. First thing I want to do is I want to show you how f of x is how we get the inverse function. That's the first thing it says. For each function, find f inverse. Okay, so how do I find f inverse? Well, it's very easy for you. First of all, I will suggest that you not use the function notation for that. We'll just call that y. Instead of calling it f of x, we'll just call it y, because it makes it easier for us to interchange x and y. So now I'm going to interchange the variables. So instead of y, I'm going to put x, and instead of x, I'm going to put y. And then like before, we're going to solve for y. So to get rid of the square root, I square both sides. So now I have x squared equals y plus 1, and then I subtract 1 from both sides, and I get that x squared minus 1 is basically the inverse. At this point, once you find the inverse, you can go ahead and go back to the notation if you want to. F inverse of x is equal to x squared minus 1. All right? Now, what is the domain and range of f and f inverse? Okay? Determine whether the f inverse is a function. Okay? This is a quadratic, a well-behaved function. We talked about that in the last section. A well-behaved function. So the domain for this function is all reals. But what about this function here? Okay? What is the domain of this function? What numbers can I put in this function? Now, you will remember that I told you guys last time that there are two issues that you have to deal with when you're talking about domain for functions, and that's division by 0, there's no division here, and the square root of a negative. And this is clearly a situation where you have a square root, so this cannot be negative. So an easy way of figuring out what the domain is to say x plus 1, the radicand, cannot be negative, so it has to be numbers that are greater than or equal to 0. So then when you solve for x, you get that x is greater than or equal to negative 1. So that becomes your domain. Your domain is any numbers that are greater than or equal to negative 1. Now, what is your range? What kind of numbers are going to come out of the function? Okay? Now, this might be hard for you to realize, but the only kind of numbers that are going to come out of this function are numbers that are 0 or greater. In other words, the square root of a number is always going to be positive. You're never going to have the square, because you can't put negatives in here, so the square root of a negative number won't even happen. You can put 0. If you put negative 1 in here for x, negative 1 plus 1 will be 0, so the square root of 0 is 0. So it's possible for the output to be 0. And then it's possible for the output to be positive, but it's never possible for the output of this function to be negative. So for that reason, the range is greater than or equal to 0. Now that is the domain of f. This is pertaining to the f function, okay? Now, we need to also answer the question of what is the domain and range of the inverse function. And remember that what we said earlier was that the domain and range for the inverse functions are interchanged, remember? So if the domain of the normal function is x greater than or equal to 1, this domain becomes the range of the inverse. So here's the range. But you do have to keep the letters correct. You know, x is input, y is output. So range is output, so we're going to put y. But the fact that it says greater than or equal to negative 1, it's greater than or equal to negative 1. They'll have the same domain as the range, but with a different letter. Okay? So again, the domain of the function was x greater than or equal to negative 1. So the range of the inverse is y greater than or equal to negative 1. And the same way, if the range of the normal function is y greater than or equal to 0, then the domain of the inverse is x greater than or equal to 0. And again, if you look at this, function here, x squared minus 1, just out of curiosity, I mean, they're not asking us to graph it, but if I was graphing it, x squared minus 1 would be shifted 1 unit down, and the parabola would be upside down. And so you could see how the range would be from negative 1 below. which is kind of what this is saying. So there you go. I believe that that is, I'm sorry, I don't know why I graphed that upside down. Sorry, do not. I just realized my mistake there. Don't shoot me. It's still shifted 1 unit down, but the parabola is not upside down. This is a positive. So you can see that the range is, the y values go from -1 up, which is what that says, y greater than or equal to -1. So we have found the inverse. There it is, x squared minus 1. The domain and range of f, domain, range of f, domain and range of f inverse, domain and range of f inverse, and lastly, whether f inverse is a function. Because this is a well-behaved function, it has no square roots, it has no division by 0, then yes, it is a function. There's only one piece to the function, so there you go. All right, now by the way, the quadratics are always going to be the harder ones. But now we have this guy, so again, we're going to do the same thing. We are going to start by, we're going to start by making this y, and then we're going to invert x equals 10 minus 3y. Then we're going to solve for y, so x minus 10 equals -3y, divide by -3, and then y equals negative x minus 10 over 3. There's my function. So if I want to go back to my inverse notation, there I am. Okay? Now, this is an easier one because it's not weird and quadratic-like. So the domain of the function is all reals. There's no square roots, no division by 0. The other one had a square root, so it was kind of weird. The range for the function is all reals. And because those are both all reals, when you do the inverse function, the domain of the inverse function is also all reals because they interchange, but if they're both the same, it's not going to make a difference. And the range here is all reals. And are these both functions? Yes, they are. The only time that would not happen is if you had a plus or minus in front, which we don't have in this case. So that pretty much takes care of how you do that little guy. And so now there's a couple of examples that I want you to try. And then this is our last example. It's kind of like a trick question, if you will. And it's example, I believe we're on example 5. And it's asking me, it's giving me a function, f of x equals x minus 7 over 6. And then it's telling me to find f inverse of f of 374 and f of f inverse of negative 99 pi. Now, this is a funny question because you're probably stressing out right now, but I don't want you to stress out. And the amount of work that I'm going to do right now is in no way what I want you to do, but I do want to show you why this is true. So the first thing I'm going to do is find the inverse because it wants me to do composition. Okay, so if I go x equals y minus 7 over 6, then I'm going to get times 6 times 6, so 6x equals y minus 7, then I'm going to add 7, so it turns out that f inverse of x is equal to 6x plus 7, okay? Now remember, this never told me to find the inverse function. They gave me this function, and I determined that this is the inverse function, and now they want me to do f inverse of f. That literally means, people, that they want me to do f inverse of the f function. This is the notation that I like. Remember? F inverse of f. I don't like that little notation, so I'm going to rewrite it this way, which is basically f inverse of f. What is the f function? X minus 7 over 6. Right? Okay? And because the x value here is 374, we're going to put 374 in there. But this is actually supposed to be a lot easier than it actually sounds. What's going to happen when I put f inverse of f? The f function, the f inverse function is 6x plus 7. 6x plus 7. What's going to go inside the x's spot? X minus 7 over 6. Okay? So what's going to happen is those are going to cancel. X minus 7 plus 7. So my answer is x. Well, what is x? 374. So I am pleading with you right now that the answer to this question is 374. Well, that was a lot of work to get back to the same exact answer that we started with. Let me remind you that we already discussed at the beginning. The inverse and the function together will always cancel, leaving you with x. So you're supposed to look at that and say inverse f cancels. The answer is negative 99 pi. Okay? Let me show you one other way so you can, again, see what's happening here. This is saying f inverse of f of 374. Okay? So what I'm supposed to do in this case is to start from the inside. I'm going to start from this inside and go to the f function and plug in 374. So where's the f function? Over here. So if I get f of 374, it means I'm going to go x, which is 374, subtract 7, and divide by 6. So 374 minus 7 is 367. 367 divided by 6 is a fraction that doesn't reduce. So we're stuck with that, okay? Now, that means that f of 374 is this ugly fraction. So instead of f of 374, I'm going to replace it with 367 divided by 6. Okay? So I'm replacing the f of 374 with what it equals, 367 over 6. So I plug that into the inverse function. And the inverse function is 6x plus 7. So 6 times 367 divided by 6 plus 7. What's going to happen? The 6's are going to cancel. 367 plus 7 is 374. Back to the original answer. Originally, I plugged in 374. See, I plugged in 374. Out came this. This goes in, and back I am to the 374. That's a lot of work. And again, I'm not suggesting that when you do the homework that you do all that work. What I want you to get from this lecture is that when you have the function and the inverse together composed like that, they always cancel and equal whatever the x value was. So basically, they gave me two problems to do here. When I saw, so I'm going to erase all this nonsense, okay, because that's very rare for me to call it nonsense, but I hope that you heard what I was saying. And let's just continue here. It was kind of like a trick question, and I'm hoping that you don't get tricked by it in your homework, okay? But this is like a trick question, okay? They tell me that the function is x minus 7 over 6, and they want me to find f inverse of f. If in fact these are the inverse functions, they will cancel, and the answer will be the x value, which is 374. F of f inverse cancels, the answer will be negative 99 pi. No work to show, those are the answers. Okay, so right now, I would like to give you a couple, your last do-it-yourself problem. And I want you to, for f of x equals 5x plus 11, I would like for you to find f inverse of f of 777 and f of f inverse of negative 5,802. Okay, when you've done that, you will have completed this lesson's assignment, or sorry, this lesson's notes. Now, because a lot of you will be gone on your sophomore trip, I am going to go ahead and give you the assignment in this lesson so that you can have it without having to worry about where you're going to get it. It's 3 through 57 multiples of 3. All right? And I apologize that this lesson was a little bit longer video-wise, but there is your assignment. Thank you for watching.